means I can skip right past this slide here. And I'm going to jump right into what FlexSim is, and as a precursor to that, what discrete event simulation is, because that's what FlexSim does. So what I've got coming up is a definition right from the Autodesk website. It was amazing. That's what AI brought up when I did a quick check on it as well, so I'll go with it. But discrete event simulation, it's a technique to model the operation of a system. Could be a very complex system, could be a very simple system. Today, we're going to be keeping things more on the simple level to give you a feel for how things operate. I'm not going to try and show a huge simulation of the flow of people through Newark Airport or something like that. Can the system do it? Yes, but that's not going to do a good job of showing you the hows. And from the hows, we'll talk a bit about the whys. So it's a modeling technique to look at an operational system as a series of individual events, discrete events. It's used to analyze simple and complex processes and systems, and those processes can interact in the overall system. They can be standalone. Again, it can be treated as at the very simple level, but that can quickly grow to more and more complex system as you take your scope wider and wider. It's looking at interactions at distinct moments in time. The way I tend to think of it is, my first job out of college, I went to work for a heavy-duty truck manufacturer. So I picture the assembly line at our local plant. And specifically, I like to think in terms of the painting painting line. And the series of interactions and changes could be a raw hood's put on the conveyor, goes into the painting booth, gets painted, paint gets cured, comes out. Those are distinct events. The interactions are the painter, the conveyor, the hood, all those different things taking place. Time, how much time does it take to paint? How much time does it take for the paint to cure, and so on. That would be a use for FlexSim if I wanted to analyze that type of a setup. Those events occur at specific points in times and mark a change in state of the system. The hood's painted. That's a change because it came in unpainted. Time, when it went into the paint booth. Time again, when it came out of the paint booth. So on. Doesn't necessarily mean it's a specific point in time like it's 12:05 in the afternoon, but it could. You could be using this to model the flow of people through a restaurant. Okay, you know you're going to get more of a lunch crowd starting at 11:30 and going till 1:30 than you will at 2:30 in the afternoon. So it can be a specific time or just a time delta from somewhere else. Discrete event, it's a way of taking a look at processes. I know it says production processes, and that's where my background always leads me. But it processes over time, and it allows you to try adjustments. What ifs? What if we added a second line for painting? What if we added another rack in the curing room? Well, do we have room for it? Let's see if it's worth it before we go and spend the money to put that in there. There's also ways you could use this if you know what my incoming orders are like. I could use this as input then to see what do I need to get through 2 weeks from now when I need to be shipping those orders. So I can use it kind of like a warm-up, a precursor for what I'm going to need to change in my facility next week if my resources are actually that flexible. The way to look at a discrete event simulation is the overall system. Take a look at entities, events, and resources. So an entity, the object moving through the system, the box moving down the conveyor line, the box being carried over to a new area, or to be a little more specific, that hood That's arriving at incoming inspection. It's being inspected, then it's going and being put into storage. Then when it's needed, it's coming out of storage and going and being put on the chain conveyor to go through the paint system, and so on. But that entity, in this case, it's the truck hood. Those events, it's when things happen. It's the hood arrives. Okay, that was an event. It's put into storage. That's an event. A need for it to come out, that's an event. It goes into the paint line. That's an event. Same thing, again, going back to that restaurant idea, a customer arrives. Definitely an event. The resources, well, could be down to the level of the paint, but the one I keep thinking of is either the robot if it's an automated painting setup, or the painter if it's a manual setup, or even a custom setup. So that's a resource. Do I need to have a forklift available to move a object out of the rack and onto the conveyor line? That's a resource. And then the simulation is the actual running of the setup to go through those events that are taking place, follow the entities through the system, and see what changes in my resources might affect my overall performance. So you're doing a simulation for a reason. It's not just to make pretty pictures. You're looking at to see whether it's worth spending the money for a capital outlay or hiring another person, or it's those what ifs that you're using the simulation to help you figure out. FlexSim itself, you can take a look at it in 3 general categories: 3D model, process flow, and experimenter. So the 3D model, I can build a model from existing pre-built components. I've got a library of existing things that I can bring into my model, put them where I want them to be, and connect them together. As far as putting them where I want them to be, I could bring in an AutoCAD floor plan. Maybe you already have one for your existing facility, and use that to locate where I want the various pieces to be. I could also create new, I'm going to call them skins for those 3D models. So it's still a processor, and you'll see what a processor is coming up very shortly. But I could make it look like my painting booth rather than a more generic piece like you'll see today. And then, since I'm building it in the 3D world, I can apply motion. I can say that the person that is moving this widget from the incoming parts queue to the actual machine doing the work has to actually move. All right, well, where is that person allowed to move? Where is that person not allowed to move? Do we have any bottlenecks when you have 2 people, 3 people, 4 people trying to move? So A-Star Navigator gives you a way to put motion to your 3D model. Process flow is another way of approaching things. And there you're working with very granular tools. You're going and grabbing individual pieces of code, if you will. Code blocks is probably a better phrase for it. And you're using them to build what your process is going to be. The way I think of it is, at the 3D model stage, if I wanted to, I could go out and buy an existing model of the Millennium Falcon. I wouldn't, but I could. Process flow, I'd be going out and buying the kit and building those individual Lego blocks until I came up with the Millennium Falcon. And I build them in the way that I want to get the actual piece that I'm trying to create. In the course of doing that, especially, well, in FlexSim, not in the Millennium Falcon, but in FlexSim, I'm probably going to be building up some chunks of code that are actually representing things like the painting booth. Well, I probably want to save that off and reuse that for future use when I try and do another painting booth in the future. So I can create my own library of my own equipment, my own processes, and save them for easy reuse later. And then in the end, as I said before, the idea with FlexSim is you're trying to answer what ifs. You're trying to answer questions. All right. Experimenter is a tool that will take a model that was made from 3D models, from process flow, from a combination of those two, a hybrid model of those two, but allows me to run a lot of what ifs very quickly. We'll take a look at that as we get to the end of things. So let's go and build just a basic, very simple process right from scratch. So I'll come down to trying to get my mouse to pay attention to me. There we go. So there's my FlexSim. I just fire it up and I'm going to start a brand new model. Right at the beginning, I'm going to confirm that I want to work with the units as shown. Length will stay in meters, but I've got a variety of things I could change. Time, so on and so on. I'll accept this. And there is my empty playing field. I'm in a 3D model here. On the left-hand side, here's my library of existing pieces that I can start with. Well, I could start with a source. And a source is basically a way of bringing things into your model, into your simulation. It's a starting point. It's a piece of magic where now, boom, a box is going to appear. In fact, it's going to appear and then get put immediately into a waiting area, a queue. Now, what I'm going to do is take a little bit of a finer look at that source. Right now, the source is going to bring in things with a random distribution that follows an exponential style of statistical distribution. Looks kind of like this, and on average, boxes can appear every 10 seconds. Okay, technically 9.98, but it's close enough for me. Fair number may come in quicker than that, and a lesser number are going to be trailing off. We're not going to have nearly as many showing up every 40 seconds as we do every 5 seconds. On average, though, every 10 seconds, something's going to appear. To connect that to the queue, I go and I drag a connector between these. Boom. Now the source is going to create an object. It's going to create a box. It's going to send it to that queue on an average of every 10 seconds. Okay. From the queue, I'm going to have it go to a processor, generic piece of equipment. I'll connect those two. And now boxes can be created, put immediately into the queue, and then as soon as the processor is ready, that box is going to get shoved over there, and then move on. And I need some place for them to go when it's all finished, so I'll create a sink over here. This is where the objects exit the simulation. And I need to connect that in. There we go, the bare bone basic model. And I'll go ahead and run it. By default, it starts off running at about 4 times real speed, but I can crank that up quite a bit. There we go. So running a little more than 8 times real speed. And you can see that even though they're being created on average every 10 seconds, I get a backlog sitting in the queue because there are some that are being made less than 10 seconds apart. And sometimes that backlog clears a bit because the next one's being made more than 10 seconds apart. And now just add a little more variety to it. I'll bring in a person to move those around. And I'll say that, all right, you're going to connect there. So the queue is aware of that person. I'll tell the queue to actually use that person. And now I'll reset and run it again. I reset because I made a change. And now you can see now the person is starting to move it. The Problem is that person's taking some time, and now we're seeing more and more of a backlog. This might be something that, gee, I'm going to want to use the experimenter on, not this exact one, but use the experimenter on to try and figure out what we should be doing to clear that backlog. So that's the basics of a 3D model. You've got a library. You can add to that library, customize pieces that are in there. I'm using all the default settings, that 10-second processing time, that on average 10-second creation time, and letting it work. From here, though, I'm going to go and bring in, there we go, something a little more sophisticated. So here, this one has the floor plan already imported from AutoCAD. It was brought in, background dropped in place. In fact, let me go ahead and give you the eagle eye view here. So the cue was dropped in a location where the where it made sense from the floor plan point of view. The source is just the source; it's still out there. In addition to that, from an A-star point of view, from the navigation, the workflow, the movement of the operator point of view, we've added some barriers here. We see these as walls. I've added some dividers in here. You can see there's a divider here, and what this is saying is the operator can only go in through this door, or this opening. Can go in or out through the inner ones here, but it's only allowed to go in through here. And then there's also another area keep out. For whatever reason, there's something blocking that location. And this is something that, again, we do in the introductory class, work right through this. I don't know what that thing is that's blocking it. And you could use your imagination. It's, I don't know, it's the stairs up to the mezzanine or something like that. And that might be something that you're going to want to explore. What if we move that around? Change it. And if I start running this again, I hit reset here, which is a good habit to be every time you run it. And when I did that, the A-stars grid popped up. So the area in blue, this is the area that A-star is caring about, where the navigation is being looked at. And you see these yellow crosses. I'll zoom in a little bit so you see a little better. Those crosses are indicating how an operator could move if it was in this square. It could move northeast, south, and west. No problem. Oh, but as we get over here, the operator's not allowed to move west again. No, only allowed to come in, can't go out. As opposed to over here, east and west are both available. Now again, this is a nice, simple process here. We'll let it get started. But it's showing how the motion is taking place and what the operator can do accordingly. The other thing that's going on here is we're getting two different kinds of boxes. We're getting red ones and green ones. And it's not because people have already started putting up Christmas decorations in my neighborhood. And no, I'm not bitter about that at all. It's to indicate a different product that might have to go through a different process. So maybe it's a different SKU. One's a white hood, the other's a blue hood. Whatever, it's just to indicate differences. The other thing you'll notice is that those differences push it to a different processor. So the reds only can go to the top one, the greens can only go to the bottom one. Further, if I wanted to see where things are going, I could turn on some visual clues. I'm already showing the nodes. How about if I show where the person is going? Okay, there's a lot of traffic through here. There's trying to be more traffic through here, and there's some traffic. What would happen if we move where that barrier is, resize that barrier, move where the queue is compared to where the barrier is, and so on. I don't have this one running. I notice it's looking very jumpy on my screen display, and I don't know if that's because it's going out to the internet and coming back in, or if it's actually showing up jumpy on your end of things. Please be assured it's very smooth on my screen in front of me. But now I can start taking a look at some what ifs. The other thing I can notice is that backlog, that work in progress, is really starting to build here. So again, indication that maybe something needs to be done. All right, I'll stop that one. Pop back over to the PowerPoint for just a moment. So that was the A-star navigation. And as I said, I could use this to see what would happen if I had two operators. And A-star allows me to say those two are not allowed to occupy the same space at the same time, basically avoid collisions. I also would have a dispatcher. That's a way of saying who gets what on those operators, if there was some kind of priority or something that needed to be considered there. Process flow, again, this is the granular way of doing things. So if I go back to the idea of painting the hood for a truck, it could be the incoming hood is inspected. Well, what happens? Well, when the hood gets to inspection, we have to get a hold of an inspector. Okay. And then it's going to take some time. And when the inspector's done, then it can go to painting. It's not shown here, but there could be, if it fails inspection, where does it go from there? Goes through painting. You have to acquire the painter. This painter might be busy painting something else. Okay, then we have to wait until that painter's available. Once the painting's done, then it needs to go to the curing racks. Well, again, you need to make sure you have a curing rack available. And this would be a case for what if. What if I added some more inspectors or some more painters or some more curing racks? What could happen there? What if I came up with a new process that slowed down some of those delays? What if the paint needed to slow down the painting time was twice as expensive? Is it worth it? Those are the kinds of things that I could answer with the, or at least get a better feel for with FlexSim. So I'll go ahead and open up the idea of that flow model. And again, this is one we do during our introductory class. And we'll go ahead and close those. And basically, I've got a typo in there somewhere where it doesn't know what to do at time equals 0. But there's my process flow. And different pieces. When I go and hit run, you're going to see dots starting to appear. So instead of having a person walking around holding a box, I've got a token. Token is created up here. It's assigned a color, and based on the color, goes into line 1, line 2, or line 3. Red goes to line 1, green goes to line 2, and blue goes to line 3, and you can see how those tokens are working their way through the system. In addition, you can see whether or not that inspector has a backlog. Right now it's inspecting one thing, but every now and then you'll see a backlog flash up. 2 items, 3 items, we got a little bit of a backlog there. And it could be coming from this inspection, but there was also an inspection down here. So I can get very granular very quick. But what I can't do with this one is if the inspection station for this is remote from the inspection station from that, I'm not going to be able to account for the specific time to get from A to B unless I would somehow bake it into the delay that I'm assuming is the inspection time. And that's maybe not fair, because that delay may not happen if the inspector was already here and the next piece came in and there was nothing waiting down there. So to take care of that, what we can do is hybrid. Mix and match that process flow directly with the 3D model. In the one you see here, we've got some code that's taking a look at a list, and that list is helping to figure out what needs to get loaded on the pallet. It's working in conjunction with this table. So the different color palettes are representing different orders, or order mixes, better way of phrasing it. So if it's a red palette, we need what's on row 1. And these could have been renumbered. I wish I'd done that now, but that's 20/20 hindsight. So the red palettes, we need 6 of the red boxes, 2 of the green boxes, and 4 of the blue boxes. Yes, these could have been renamed as well. When I get to a green, then the mix is 4, 6, and 2. When I get to a blue, which is what that one is there, it's 2, 4, and 6. Well, we need to have the right ones in the queue so we can fill a pallet. And then what the process flow is doing is taking care of reducing the queue by the amount and adding them to the piece. So if I go and open up that model, and make sure I hopefully open the right one. There we go, pallet loading hybrid. The other one that might bring up at the end of the session is a very much more complex system. Again, in this webinar, I'm trying to stay simple, trying to keep things to get the concept across rather than trying to throw a lot of really fancy pictures on the screen. Believe me, I've got some fancy pictures I can put up there if it be desired. So there we go. There's the system, a little bit of a different viewpoint from where we were before. And I'll go ahead and run it and bounce it up a little bit. It takes a while for the first pallet to arrive, but there's the piece. Now we're starting to get some there. Slow it down a little bit. A little bit of a backlog. So, gee, we got another pallet. Think of it as another order right away. Okay, so now we got to fill that. And it's taking a look and seeing what color it is and pulling appropriately from the two. So for things that you can build in the 3D model and you're worried about motion and movement, the time involved that, or you have a good reason for having a really good picture, then that is a tool. But to get down into the nitty-gritty, you may find you need to mix in some of the process flow as well. System certainly can do that. Bouncing back over to the PowerPoint. Now, how do you decide what you need to do? I could sit there and manually tweak each of those models. Well, what if I manually reduce the failure rate? What if I manually add another person? And if I manually do this, manually do that, run it and see what the numbers do. As you could probably guess from the way I'm phrasing it, not the most efficient way that there is. The software has a tool called Experimenter. And what it does is it takes a look at the code that you're generating between your 3D model and your process flow. So you can look at the core code, give you a chance to run a number of different scenarios, but it's not doing any of the thing with the 3D model. It's not moving tokens around on the screen even. It's just doing it all in the background. So it runs much, much faster. That way you can develop your scenarios that you want to try and see what the benefits are. So then you can decide what is it worth you spending your resources on. Because if you're like most people, you do not have infinite resources, whether it's time, money, space. You're going to need to pick something. I have this nasty feeling. Oh, good. Phew, I thought I'd opened the wrong one. Okay. So as I was saying, I could go ahead and run this. And I hadn't talked about what the kind of reports I could do. These are live reports to see what's happening. Oh, I was still down at the 4 times real speed. Let's just get that up and get that moving a little bit for things to start happening. Yeah, we're running 300 times real speed, so that poor person is just going nuts. But you can see the mix that's taking place, how they're getting put into the queues, and then going through the process, or the results of the process, then put them into a different queue, which then feeds into, this is called a combiner, essentially loading up the pallet with whatever the given order needs. And we're keeping track of how many pallets per hour we're doing, and we're up in around 4.5 or so pallets per hour, sometimes spiking up to 5, sometimes dropping lower, but it looks like it's in that somewhere between 4.5 and 5. Okay, so let's call that our baseline. And our baseline is we've got one person doing all the work, we've got one machine, and we've got a failure rate we're assuming of 20%. So that is an assumption that we're working with. Well, as I said, we're pallets per hour, and you can see this number is changing. It might be an eye chart to see on your screen, but that is definitely changing. It's up in the 4.6, 4.7 with a little bit of a bump up and up in the 4.9s. Okay, and the operator is about 62% utilized. So even though it looked like they were going a mile a minute, that's only because I had the speed 50 times what you would normally expect. So let's stop that. Give them a little bit of a break there. And I'm going to run something called Experimenter. Experimenter is taking a look at my model and what I've identified as parameters. That was the same as what we just saw in that tab there. The team size, one person. Well, let's see what happens if we make it 2. All right. Number of machines. Failure rate. And then let's see what variations. Double number of people, keep everything else the same. Go back to the single person, double the machines, so on. Okay. Granted, on this system, that could have been run fairly quickly, but it still would have taken some time, and I have to note that down. So what I'm going to do instead is I'm going to say we'll give everything a good hour to get up to speed, and then we'll run it for another 10 hours from there. And for each one of those each one of those scenarios, we'll run through 30 tries because we've got some statistical distribution. We got some randomness. Let's see what the randomness does to the results, not just take a single data point, but let's see 30 data points for each one of these scenarios. Now, I'm going to go ahead and delete the results because I did that before. There's the 4 scenarios it's going to run. I only have one experiment set up. I'll go ahead and run it. And you'll see, okay, everything's been primed and now it's actually running them. And I would say it's a little bit faster than I would do it by hand. Or sorry, not by hand, by changing each one of those parameters and doing another batch. And especially it's running faster than if I was going to do each one of those and then try and analyze the results. So what I can do here instead, I'll pull this over a little bit and make it a bit bigger, is here's what we started with, and gee, we had a median of 6.1 pallets per hour. And between 25% and 75% of them, there was my range in that. And my total range, we had something up there at 6.9, and we had something way down at 5.3. So fairly tight, typical. Oh, we add a team member. We'll have some time where apparently that team member's not really helping. Boy, we'll run sometimes when it does, and overall, we're now up around 6.5. What if we only had one person, but we added a second machine? Oh, interesting. Same median. What if we paid a little more money to get some better quality raw material coming in? Or somehow we're able to do some rework on the front end to clean up any possible failures? What if we took that failure rate from an assumed 20% to assumed 5%? We get a little bit better there too. So each one of these scenarios, there's a cost associated with that. I have a chance to decide which one I want to do. Now, when I first looked at this, I went, which one do I want to do? Well, this is something maybe I could do as early as next week, bring somebody else in, train them, get them working. Adding a machine, that could take a month, could take a year, could take 5 years. Reduced failure rate, that would be ongoing negotiations, maybe if it's coming directly from a supplier, or maybe it's a front-end process, or maybe it's a way of tweaking our overall process so it's a little more forgiving for any things it finds, but that one's probably going to take long term. Which should I do? Well, maybe instead of just looking at where all the different 30 individual runs went, maybe I should take a look and see how they compare. So from the baseline, we definitely got some improvement. Statistically speaking, we got some improvement in all three of those. As I mentioned, probably adding in team members the quickest, easiest. There is money involved, definitely, but it's the quickest. Is it any better than the other two? No. So really, from an overall output point of view, this simulation says that it doesn't matter which one of these I do, I'm going to get the same improvement. So maybe that tells me I would go and add a team member for the short term, maybe for 6 months or so, while I work on something overall to get my throughput up where I think I'm going to need it. And that's the power of the experimenter. I can do those what ifs. I can do them very quickly. Here's a what if. I'm sure this has never happened to anybody. Boss comes over and says, well, what if we take a look at a different way of doing it? And of course, the right answer is yes, sir. So let's say that this is all of the above. No, that's kind of silly because he's not going to want to spend the money on the equipment that's not going to arrive for 6 months. Let's just say plus operator and reduced. I can type today. I'm just going to say FR for failure rate. So let's say we do two things. I'm going to make that be 2. I'm going to say, maybe I can get that down. Maybe I can cut my failure rate in half. Negotiations, whatever. Okay, I've got a brand new scenario I want to run. Do it for the same 30, the same settings here. Sounds good to me. I don't need to delete all those results. Here's my scenario I haven't run yet. I'm just going to go ahead and run. And it's going to look and say, that's the only one that actually needs to go through the system. There, we're done. Did I gain anything? Sir, it was a really good idea, but the model just doesn't prove it out. It really, by itself, didn't really seem like it helped enough. Why don't we just go with adding the team member and see what we can do from there? Are you sure? Well, yeah. If the model that I built is an accurate representation of what we're doing on the plant floor, then yeah, I'm sure. And I do want to leave you with that thought. Just like any other simulation, whether it's stress analysis, whether it's circuit analysis, any kind of simulation, you're doing just that. You're simulating the real world. So it's going to be as good and as bad as the care that's put into that simulation. Sorry, I always feel I need that disclaimer. Having watched people with stress analysis, oh, this will never break. No, that's not how you interpret that. So once again, with FlexSim, we've got the 3D model where we can work from an existing library. We can work with existing floor plans, typically through AutoCAD. We can work with importing 3D models, and FlexSim is a relatively new acquisition by Autodesk. So I'm really looking forward to what the future brings on the 3D modeling end of things. In the past, when Autodesk has purchased a simulation company, they've put their resources heavily into the user interface, and then also the integration with the rest of the Autodesk world, whether it be Revit, Inventor, Fusion, what have you. So I've got my fingers crossed. I don't know of anything specifically coming down the road, but based on past history, I'm looking forward to that. If the pre-built doesn't have what I want, then I'm going to go and use those individual little building blocks, those code blocks, to create what I need. And then I'm going to save it, because I'm going to want it again in the future. And then I'm going to take a look and see what I want to do. Do I want to add a person? Do I want to add a machine? Am I going to gain anything by doing both? So that is an introduction to FlexSim. I appreciate your time and your attention. At this point, I don't know that there's been any questions. I don't see any questions. I am going to put some eye candy up on the screen here. Give you a chance to think of any questions. This is the restaurant model, and see, what time do we have it right now? I'll just reset and let it run, but I'll speed it up until people start arriving. The part that looks really funny to me is how fast people eat, because when you have something just sitting there idle like an operator, you can control what that operator does. In this case, they're sitting and there's a slight movement on the sitting. You can have somebody standing with a slight movement and so on. The other part I get, for those of you that know me, I have a little bit of a sense of humor. I like the way the meal floats above the table. But if you stand back, you go, all right, somebody is spending some time eating. It's a random number for the amount of time there. And the number of people coming in and so on is random as well. I've run this where I've had nobody in the queue. What time is it showing right now? Well, it's 1 in the morning. Okay, it must be a 24-hour diner. But if I bounce that up, I've had that queue with 30 people in it as it got close to lunch. See, 3 in the morning. I would question the input date on this one, but that's me. Cleaning various tables, that was in there. And there we go. Now we got the breakfast crowd. Whoops. 1/10 real speed as the person's taking his carry-out. There we go. All right. Still not seeing any questions. Any thoughts, concerns? My suggestion at this point is I've been showing the basics of how the software works. Yes, that person did walk right through the table. But if you want to see or discuss something more specific to your needs and wants, contact your Hagerman sales representative. Hi, Eddie. So you've got your hand up. Do you have a question you want to put in? Oh, you're welcome, Peter. Keith, do I have any experience with the optimizers related to the experimenter? I've not dived down into that. So I can honestly say at this point, not yet. No, I've been busy learning. It's a new language for me. So trying to get the front end first before I dive too far into the back end. Is the recording going to be sent to you? I believe that the plan, and Ashley can hopefully confirm that, is that a link will be sent to the attendees as well as the questionnaire, and I do believe it also will get posted by Hagerman.
Yes, that is correct.
And as those tables free up, their colors are changing, indicating that they're free. And I believe the green one's indicating that it needs a wipe down. Or, sorry, probably cleaning. But anyway, it's fun taking a look at somebody else's model and trying to figure out what's going on. Keith, as far as the optimizer, again, specific questions, be glad to get you in touch with somebody, probably somebody with Autodesk to answer any direct questions there. How important is getting the random timing correct rather than just using a set time? The way I'm going to answer that one is yes, it's going to be critical, but if you don't have the information, start with what you have. The better the information, the better your simulation is going to be. But if you don't have anything, I wouldn't wait to have a in-depth time study of incoming done before starting to take a look at it. But just keep in mind that results right now are made with assumptions, and then work in the actual real-world data later on. Mr. Henry, if you are who I think you are, it's been a little while. How long did it take to get to a level of comfort running these simulations? The introductory ones, that was pretty well after taking the introductory course and exploring for a little bit. As far as comfort running simulations, well, you phrased it in a way that's really easy for me. I can run a simulation. It's just one button up there. It says run. But as far as developing a very complex interaction, I'm continually looking at other people's simulations and trying to figure out and understand the nuances of what they did. So I'm learning. I don't feel too bad setting up and running a relatively complex, but using stock tools. It's getting outside of that stock where I am definitely learning with every existing simulation that I look at. That's probably the best way I can answer that one. Give another minute or so. If no more questions come in, I'm thinking that we'll wrap up at 10 till the hour. I do have another model I could load. It's one, well, there's all kinds of extremely fancy models available if you go out and look on YouTube, just to be blunt. There's a fantastic warehouse racking system, complete with automated loading and unloading of, I think it's an 8-tier system, and there's how many, 6 of those tiers across the warehouse loading up to a conveyor system. There's a AGV running around the background. I didn't bring that one up because, like I said, I'm going and getting into the nuances, and that one I haven't gotten to the point where I feel comfortable talking about it yet, because there's a lot in there that I want to explore. Yes, as far as downloading other people's simulations, oh shoot, I don't have the website up. Autodesk website, if you go to the FlexSim product page, they have tutorials. They have the tutorials is where I usually go to take a look and see what's in there. Keith, that's probably where to point you towards right there. And that way you can see the model, not just look at the movies saved from it like you're kind of stuck with if you go to YouTube. Let's see. See if I can. And Keith, if you'd like to reach out to us, certainly can go there. I'm sorry, I'm taking a look at going through my pieces there. So here's the Autodesk learning catalog, and I did a filter on FlexSim. So this is a place that I take a look and learn from what other people have done. There's a lot here. So Autodesk.com, learning in the catalog. Let's see. Concerning the source and sink, does this allow linkage between models with the models with the output stored from one model used? Yes. Yes, you definitely can. You wouldn't actually put it into a sink at that point. You would put it into a queue. Just have it hold there. So the source brings something into the overall system, and the sink removes it from the system. In between, you'd be using queues in the 3D world to store things till they're ready to be used. And there's pre-built models for racks and items on that, and all kinds of logic you can put in place to have the based on what the SKU is for something, which bay it goes into in the rack system, and so on and so on. There's a lot of complexity in here. Again, today, just trying to keep it at the convenient level, introductory level. There we go. Words fail. All right. Give another minute or two for any other questions. Again, it is interesting seeing the difference in the smoothness of the animation on my screen versus what I'm seeing as the replay of the webinar coming back in on another screen. All right. Have a good day, Peter. For the rest of you, looks like we've lost a couple of others. Again, hopefully this got you enough information that you can figure out what questions you want to ask, and we can go deeper with you specifically.